We've all seen it. You're in the kitchen with a glass of water. You have a hankering for some Kool-Aid, so you start by grabbing the sugar and tossing a couple spoons of it into your glass. By the time you get the flavoring packet, the sugar's gone, dissolved in the water. On the other hand, later that night you have to do the dishes after a big meal. You're slaving over the hot water, and finally you put the last plate away, and you notice these shiny little bubbles in the dirty, dirty dishwater. Those little bubbles are oil and fat that you rinsed off the dishes, not going away, mocking you with this refusal to dissolve in water. Have you ever wondered why these things happen? It's all caused by the little guys, the hydrophobic and hydrophilic parts of molecules that make up oils and sugars. What's a molecule, you inquire? What are hydrophilic and hydrophobic, you ask? How can sugar or oil be scared of hydras, you gasp in disbelief? To answer these questions, we need to take a step back and start with elements. Now, when I say elements, we're not talking about this or this, we're talking about this, the table of elements. Pioneered in 1869 by Russian chemist Dmitry Mendeleev, it lists all of the elements that make up everything we know in a neat and orderly fashion. These elements can combine to make molecules. Water, for example, is H2O, which is created when two hydrogen atoms, which have positive charges, share their electrons, a particle with a negative charge that floats around an element's atom, with an oxygen atom, which has a negative charge. In the world of elements, opposites attract, so hydrogen and oxygen form bonds that are polar and covalent bonds, which means their molecules have a positive and negative side. This molecule can then bond with other H2O molecules through their hydrogen and oxygen atoms and link up between billions of other molecules and make a glass of water. Sugar dissolves in water because of another elemental law, like dissolves like. There are several types of sugar: sucrose, fructose, potatoes. To match the example above, we'll go with sucrose, aka white sugar. Sucrose is a molecule made of 22 hydrogen atoms, 12 carbon atoms, and 11 oxygen atoms. This combination of bonds makes sucrose polar as well as hydrophilic, meaning it loves water. When a sucrose molecule is surrounded by H2O molecules, it is basically pulled apart by H2O and dissolves. This is not the end of sucrose. If one were to gently boil the mixture over a long period of time, you would be able to recover the sugar, since water has a much lower boiling point than sucrose. So how about oil? Why does oil resist a watery limbo? Oil and fats are made of a molecule called a lipid, which makes up many different things we consume daily, like proteins and wax. Well, some of us. Lipids will not dissolve in water because they are nonpolar, meaning water cannot attach to its molecules. Lipids will instead bind together in a watery environment, as they will be the only things around they are attracted to. So the next time you see oil floating around in water, don't be upset at it. Show some sympathy for the scared little hydrophobes.